Hi everyone. In this video, we are going to talk about pattern matching in Java. Pattern matching was introduced in Java since Java version 16. With some enhancement, now we have Java 21 with the latest pattern matching. So we will be going with the Java 21 for all the examples we have in this particular video. We have different kind of pattern matching available in Java. For example, we have the structural pattern matching, which is also called the selector pattern matching or the type pattern matching. Here we match certain value against the different types. Traditionally, when we work with Java, if we have certain value and we need to check what is its type, then we check with the is instance of method, right? And then we check if this thing is instance of certain type, then do this. If it is instance of something else, then do other thing. So all of those things are done with the help of instance of. And then when you need to work with that type, you need to wrap that value into that type to get the value out of it. With the help of pattern matching, we can easily match the value against certain type and then use that in the expression. Then we have the guarded pattern matching. In that case, if we have any type, but if we need to match against certain condition, then we can use the guarded pattern matching, in which we can apply a Boolean condition, and if that type satisfies that Boolean condition, then we will evaluate the expression. Otherwise, we will move on to the other pattern. Similarly, we have the deconstructor pattern matching or destructure pattern matching or record pattern matching. So in this pattern matching, we can have the record types which can be deconstructed or destructured into its values. Instead of getting the value from the reference type, we can just get the value out of the destructure or deconstructor pattern. Then we have the constant pattern, in which if we have a specific type, for example, we have integer or string, we can specifically match the values against the specific value. For example, if we have to do something with the integer value 1, then we can match that. Similarly, for other value, we can match that. We are going to see all of those examples in this video. So stay tuned and let's get started. I have the different test cases to cover the different pattern matching scenarios. We will go one by one. Let's start with the first pattern matching. So here we have one class department, and it has couple of implementations. So we have the finance and IT classes which are extending the department. Now we have one scenario in our test case. Whenever we call this get department method and pass the specific type of department, then it should return us the information of that particular department. To do this, we can simply check within this particular method if this department is instance of the IT, then do this, otherwise do the specific thing, right? And then we need to wrap that particular value within this specific type. But with Java 21, you can match that against the instance of this department is instance of IT, and we can have the reference of IT here. In this case, this IT will automatically have the type of IT. That means we need not to wrap this particular value. From here, we can just return. Here we have the IT, which is what coming from the name of the this object. I'm going to get that IT dot get name. Similarly, if we have to check another condition, we can apply that. This is one way in which we can do the pattern matching with the instance of. But we have rather simpler way that we are going to use in this particular example. We can also use this switch expression or switch statements. Now I'll just remove this thing here, and from here I'll simply use return switch, and we can pass the object to it. And here with the switch expression, we can define different cases. Those cases will have a label. We are talking about this structural pattern matching when we are matching this object with the type of IT, finance, etc. Here we will define the type labels. Those can be defined with the help of case. We have the first type IT, and we can use it like this. And here we can apply the same statement as we have used earlier. We can get the value from the IT. This is how we define the case pattern matching. You will see one error over here. It says switch expression does not cover all possible input values. With only IT, this does not cover all the possible scenarios. So we are getting the compilation error. So we can apply a default branch, and within this default case, either we can throw the exception if you don't want to handle any other type, or we can just return a default value from here. With this thing, if we just run our test case. Now let's see what happens. Here we are going to get the specific response. We have another expression to be evaluated, and here it is a finance department. So whenever we are passing the finance instance, it should return us the finance related information. The same thing we can do here, and now we can add one more case which is related to the finance. Similarly, we can handle other types as well. With pattern matching, there is one more interesting thing. Whenever we are passing an object to particular method, it can have a null value. If I'll just run this particular example here with the null value as well, getting the null pointer exception. This is coming because here we are passing the null value. Traditionally, if we need to handle this, we'll just check if non-null, then we do this, otherwise we return something else, right? But with the pattern matching, we need not to do this anymore. We can just apply here a null case. You can do whatever you want to do. For example, if you need to return something, you can do that. If you need to throw some exception, you can do that. And if we run the test, it should be successful. This pattern matching can also be done with the collection type. So here we have one method add value, we have one collection parameter, and then we have one value that needed to be added into this particular collection. There is a scenario whenever we have a list type, then we want to add the value into the 0th index. But if we have a set is unordered collection, so we need not to be bothered about the positioning of the value. We have two different behavior with the set and the list. If we need to handle that in the form of pattern matching, so let's see how we can do that. In the same way as we have seen above, we can use the return switch, and here we have the data. We need not to check the instance of list or the set, but we can just use the pattern matching here case. If we have a list type, here we need to add the value into the 0th index. We can pass the index and then the value that we have got in the input. And here we need to add one default branch. Let's throw the exception for now. For this set, add the value here without the index. Here you can see we have compilation error. It says that type in switch expression void cannot be converted to boolean. This method returns the boolean value. The list.add does not return anything. It has a return type as void. From here we will return the boolean value true. From your expression, if you need to return something, you can apply the yield, and here we have the boolean. Here we are always returning true after the list.add has been called. To handle the null scenario, we will add case null. From here we can throw the exception like this. Now if we need to handle the null and the default in the same way, we can apply them together, null and default, so it will work. We cannot apply this thing with any other values. If we are applying this case null or list in the same way, then it will go to the list first and will throw the null pointer exception. Now we will go to the test case, and here we have the test case. We have list and the set. Within list we have value 1, 2, and now we are adding value 5 to this. Should be added in the first place. And then we have the set which has the value 3 and 1, and we are adding value 4 to it. Doesn't really matter where it adds. If I run the particular test, here it is successful. Let's look at the other scenario, record pattern matching. Here we have one shape type which is an interface, and it has couple of types, circle and the rectangle. These are the record types. We can handle the record in slightly different way than the normal reference types. For that purpose, we have one unit test. Whenever we are calling this get shape method passing the rectangle type, it is giving us the response related to the rectangle. This is the same example as we have here within the department. With the records, we are going to handle it slightly different way. With the records type, we can use the deconstructor or destructure pattern match, wherein we can pass on the attributes of a constructor to the case itself. So instead of having a reference type over here, we can apply the double width or simply w and double length. And now we can use the values directly here instead of getting it from the reference type. So this is one case, and similarly, let's add the default scenario for now. We have another scenario wherein we have a square with sides 2.2. We have a rectangle that has the length and width as same. This is called the square. I have knowingly haven't created square type. We will use the rectangle for this example. If we have a rectangle which has same sides, then it is a square. For the same type, we need to return the information of the square. To work with that, we have a guarded pattern wherein we have a specific condition to be handled. Like for example, here we have width and length, and now if both of them are same, it's the square. We have a type rectangle. We have already handled it over here, so it is giving us the compilation error. But now we can add the clause with it. To add the guarded pattern, we need to apply when, and then we need to apply the Boolean condition. If the width and length are same, then we have a specific expression to be evaluated. But still we are getting the same error. Label is dominated by a preceding case label rectangle. Whenever we will call this method, and if this shape is of type rectangle, then this line will always be executed and it will never be received. If we just move it little bit up, while evaluating this pattern, it will check if it is a rectangle and it has this condition satisfied, then it will go to this particular expression. Otherwise, it will go to this expression. So these cases has to be defined in the correct order, otherwise you will get the compilation error. This is the example of the guarded pattern matching. When we work with Java code, we might be having certain design patterns. For example, we have a factory design pattern wherein we get the specific type when we pass some value. In such scenarios, we can use the pattern matching. And here we are going to look at one of the example. Here we have a method get user. Based on the enum value, we need to get the specific instance of user. Here we have user which has two types, primary and the secondary. If the category is primary, then we need to return primary user, otherwise we need to return the secondary user. For that, again, I'm going to use the switch category, and then we need to apply the cases. Case primary, here we need to return the new primary user. Name and age we need not to bother at the moment, so we'll just give some random value. Similarly, for the secondary case, I'll apply the secondary and secondary user. Here we are not getting any error to cover all these scenarios because we have already covered them within the enum type. But now if I add one more value over here, say third, we will automatically get the error within the categories. So now switch expression does not cover all possible input values, so we are getting the error. To ensure that we are not getting such errors, we can either add the default scenario and throw some kind of exceptions so that we are always sure that whenever we are introducing a new type, that has been handled in a correct way. Now let's look at the last pattern matching, which is the constant pattern matching. Here we have the get Java version and we are passing some integer value to it. Based on the integer value, we need to return the Java version. For that purpose, we can apply the constant pattern matching. It will work in the same way. Here we have the integer. With the constant pattern matching, we can actually pass the constant value within our case. For example, here if we have case 17, we can just simply return here Java 17. Similarly, for 21, we can return Java 21. Here, instead of having a type, we have the specific value of the type that we have defined within our switch. In the same way, we can work with a string or any other type as well. But here, I cannot apply string. It says that it has a required type integer and provided is a string. Whatever type we have provided within the switch, the same type of constant can be used within the case. This is how we can apply the constant pattern matching. This is all about how we can apply the pattern matching in Java. You can apply the pattern matching in your day-to-day Java coding. I hope you enjoyed this video. Thanks for watching and stay tuned for my next video. Till then, happy coding.